Welcome again, and good afternoon, everyone, and welcome to the Structural Health Monitoring or Health and Earthquake Engineering Research Platform webinar, jointly organized by SABS RDS and Quonsor Incorporation. My name is Ralph Saab, and I am the co-founder of SABS RDS with more than 20 years of experience in the research and education consultancy in the MENA and Gulf territory. SABS RDS, yet a 2-year-old company, we are gathering a background of cumulative experience of over 50 years of engineering consultancy and long-term partnership history with the research and innovation market specialists and experts. We pride ourselves in a value-added proposition into our applications challenges while reinvesting in the local market via supporting the students' projects. We help enabling the bridging of the local industry granted challenges into the domain experts. In line with the Vision 2030 and the localization of the know-how known in Saudi Arabia توطين المعرفة and the democratization of the knowledge. Our team services multiple segments in the education, the research acceleration, Industry 4.0, prognostics, aerospace and defense, 5G, power electronics, technology transfer, business coaching of startups and SMEs, and for sure, we are widely covering the topic of the day, which is the structural health and earthquake engineering research platforms. We at SABS RDS partner with well-reputable world leaders in the research industry and business consulting, such as Quonsor, NI, known as National Instruments, PTC, CB Technologies, Allied Reliability, Bitlessman, and many others. We have already established several success stories at several giants of the local market, and we are very eager to continue being part of their successful projects. SABS RDS is in perfect harmony with the NIDLIB guidelines to enable the success of the Vision 2030 of the Kingdom, with main focus on its 4 pillars: the industry, the mining, the energy, and the logistics. This success, or the success of this initiative, doesn't and cannot occur without focusing on the biggest capital here, the human assets. The human assets support via continuous training program and technology transfer. And finally, we at SABS RDS, we are looking forward to collaborate with you and to be part of this vision in our region's development. We always at SABS thrive to learn more about your challenges during this webinar. So please feel free to type your questions or comments in the chat box anytime, so we can address them at the end. Also, I would like to remind you that this webinar is recorded, and please mute your mics so that the presentation runs smoothly. As of now, I would like to introduce our first speaker from Quonsor, my colleague Tuvishan. Mr. Tuvishan Rajalusingam is the Global Digital Product Specialist at Quonsor. And as you know that Quonsor is a leader in the real-time control and mechatronics solution for education and research, where Tuvishan develops a regional partnership with universities and distributors from across the globe. We will have as well from Quonsor a second colleague, Mr. Isa Al-Badawi, the channel partner manager at Quonsor, responsible for developing the regional partnership with universities and partners in the APAC and the GCC region for Quonsor. I will be very pleased and honored that starting September, I will be having a very big tour, virtual or on-site, with Isa to cover all the important and interested key users of Quonsor in the Kingdom. So please have this in mind that we're gonna be visiting you soon as well. In addition to our pioneer presenters from Quonsor, Isa and Tuvishan, The applications engineer and support team leaders from Quonsor, Mr. Hernando and Mr. Murtada, they're gonna be joining us to answer your technical questions whenever it's needed. Mr. Murtada is an R&D with the academic application teams in the Quonsor team and the academic lead at the Q arm, and used to be as well the application lead for the self-driving car research studio. He holds a master's degree from the University of Toronto in robotics and space mechatronics. And at Quonsor, he's specialized in the software, architecture, and autonomous unmanned vehicle. Mr. Hernando is the mechanical engineer with extensive experience in the control system, mechatronics, and robotics. He had worked for over 12 years at Quonsor, and also he works closely with end users and business partners worldwide, providing them with assistance, training, and support. So for now, I would like to welcome Mr. Tuvishan. Tuvishan, the floor is yours.
Thank you very much, Ralph. Beautiful. So as Ralph mentioned, what we're here to discuss with you today is Quonsor's solutions around structural health and earthquake engineering, specifically targeted towards research. Quonsor has a good breadth and depth of engineering solutions that vary across a varying degree of engineering disciplines. Sorry for that. And we are very excited to share some of our case studies and success stories of some of the customers in these specific domains. So before we jump in specifically, I always love to give a quick overview of who we are. Quonsor is an academic company, and our name is actually an amalgamation of the words question plus answer. Being an academically focused company, we strive to empower researchers, professors, and teachers to embark on the tough journey of innovating and finding answers to some of the world's toughest problems. So we get our roots in academia because of our founder, who is actually a professor at the University of British Columbia. And over the past 30 years, we've been able to amass over 3,000 research papers that have been published on our solutions. So what I love to say globally is we're the de facto standard of research validation. Whenever you're working on a Quonsor solution, you can rest assured that you're able to validate and publish on our systems because of the robustness and the precision, along with the quality of the high fidelity solutions that we provide. So there are over 80 solutions in these product portfolios, and we're partnered right now with over 2,500 institutions globally. But I do need to bring light to the situation that's currently at bay right now. Due to the COVID situation and pandemic, we are being faced with this challenge globally, with partners and institutional customers who are asking us for support for online methodologies. So for those of you who have been able to tune into some of our early webinars, you would have learned some of these solutions that we've created and made accessible and available. But I'd like to highlight specific points specifically for civil engineering and where the future may lie for research and teaching. So this is actually Dr. Jinjun Chan from York University here in Canada. He had reached out to us asking for support for online labs to be supplemented through Quonsor's solutions and digital experiences. So Quonsor has been the world leader with regards to our hardware and real-time solutions. We have open architecture and accessible solutions that make it very intuitive for a student, professor, or instructor to take these resources, customize them by adding their own sensors, maybe modifying the actual curriculum because it comes with student and instructor curriculum, along with even modifying the controllers themselves to apply industry-specific relevant research or teaching efforts. But what we've now come to do, or what we've created as a holistic picture, is tagged on our virtualization element to our solutions, and what we are calling a parallel hardware-centric approach to virtualization. Currently, Quonsor has released 4 virtualized solutions, which is the Cube Servo 2, which is a DC servo motor, a twin rotor system called Quonsor Aero, a mobile ground robot called the Qbot 2E, and a mobile manipulator called the Q-Arm. So these solutions offer a complete introductory all the way to advanced offering for control systems, aerospace, robotics, and mobile robotics specifically. That doesn't mean that we are stopping here. Quanser envisions a future where every individual will have access to our physical hardware and virtual hardware to open up the accessibility that these solutions provide. So imagine every individual having a shake table or a active mass dampener on their actual PC, where they can explore the research efforts and teaching efforts in the coming future. So I'd like to quickly demonstrate what that looks like in a robotics context, but I want you to envision as if this was a fundamental vibrational structure that you know and love from Quanser. So in this example, we have a pick and place mechanism that's being used to articulate the aspects of control, along with really pinpointing the accessibility and interdisciplinary approaches that you could take with an offering like this. Meaning you could have somebody from computer science leverage the onboard sensors, such as the RGBD sensing camera. You can have someone from robotics or mechatronics understanding concepts of actuation, dynamics, kinematics, needing to go through the math and science and the traditional academic rigors that would be required to be able to control an aspect like this. But even further, you can take project-based learning approaches, or on the research front, an Industry 4.0 approach, where you're creating an assembly line that needs to read and react. So there are an abundance of possibilities. And right now, Quanser's engineering team is working around the clock to have more of our virtual solutions enabled. We have 4 solutions that are coming down the pipeline, being the rotary servo, the FlexLink, the ball and beam system, and our couple tank solutions, for those of you who are well aware of Quanser's solutions. And if you're not, feel free to take a look at our website for more insight in terms of how that looks. But with regards to how this could apply to a research application, because this question comes up a lot, we wanted to demonstrate using our own physical hardware along with the virtualized environment. So our director of engineering in his basement during COVID set up a custom layout with a 1/10 scale model of our Q-Car. So the Q-Car is a 1/10 scale model of a physical vehicle. And he was able to develop a simple, what he calls a simple lane keeping algorithm. And effectively, the purpose of this algorithm is to have the car throttle at near full speed while it's maintaining its center position in the middle of the lane, tracking a yellow line. So you should see an example of that here, where the car is requiring itself to effectively control its position and velocity as it's making very aggressive turns in this loop format. So effectively, what this would require is actually procurement of the physical hardware. You need some lab instruction time, and you obviously need some technical ability to be able to, one, understand the theory, but two, implement on a physical controller for this actual physical device. But let's say you start running into some problems, or you have frustration when you're actually trialing your actual algorithms. Or maybe you don't have space to actually set up a track at this scale. What we have been able to do is provide a virtualized paralleled experience where you can be validating your algorithms in our virtual environment called Quanser Interactive Labs, which is a 12-month subscription for both teaching and research efforts. And what our director of engineering was able to do was he took this platform, Quanser Interactive Labs, and he developed his lane keeping algorithm and fine-tuned it using the Qbot 2e. So on the Qbot 2e, you can see he's created his own custom layout. He's running the exact same controller with some fine adjustments to the actual steering algorithm, but in essence, he was able to finely tune the actual controller utilizing MATLAB Simulink. So again, right now at this present date, we don't have a direct tie to civil engineering or earthquake engineering, structural health monitoring, but please keep in touch with Quanser if you do see an interest of an overlap, or if you have specific projects that you'd like to embark on, because we are in the collaborative stage right now. And we'd love to hear from you in terms of your feedback as to what you would require and areas that you could leverage these solutions for your research or teaching efforts. So with that, I'd love to pass it off to my colleague who will be able to take you through the fundamental approaches of earthquake engineering and structural health monitoring on our traditional hardware systems. Take it away, Isa.
Yeah, thank you very much to Vishan and Ralph for the presentations. Hello, everyone. This is Isa Al-Badawi. So I'll be presenting an introduction talking about our solution for earthquake engineering. First of all, I would like to thank you all a lot for making the time and assisting to our webinar today. So usually what I like to start with is this sort of a slide. So as you can see from this slide, some universities with budgets in the range of millions of dollars normally build this kind of facilities that have like 3 to 4 hydraulic shakers, the same that is illustrated in the picture right there. So these type of projects are meant for specific applications. They design a specific building, 2-story building, for this sort of a shaker. And this requires a different approach, such as having like a designated building specifically for this sort of a project, and as well having a technician or an operator dedicated for this building. And it does require a lot of preparation and time to test and run applications and so on. So also the setup requires regular maintenance, and it does require different expensive part that takes months to build and deliver to the professors in case there is some sort of like a misuse of some of the parts. So for this type of applications, as Quansers, we have developed different solutions scaled down for a regular lab that you can use at a university itself. So we have developed different types of solutions that are scaled bench size solutions for students that can be used in normal regular labs. These solutions are developed specifically for academics purposes as well, and also for research applications. So we have a variety of solutions that vary from 1 axis all the way to 3 and 6 axes, and requires little to no maintenance from your end. Some of our users have been using the shake tables for almost 13, 14 years and never actually got the chance to change none of the parts. And we also took in consideration the research side of it, and we built some smart structures that goes on top of the shakers to imitate earthquake vibration studies, and you have that ability of adding your own structures in case you're looking to adopt different sorts of applications. So I will start with our benchmark scaled shaker, which is the Shake Table i40. This is a unidirectional shaker that is fed through a DC motor, as you can see from the left-hand side of the picture. It has an encoder connected to our DAC to get the real-time data. We also took in considerations the safety measures. So the system will come with 2 limit sensors, as you can see here from the pictures. Just in case the students are exposed to these sort of solutions, we want them to have a safe environment. And a built-in accelerometers as part of the station that will get data for you to implement on your software. So in terms of specifications of this shake table, it have a maximum acceleration of 1G at a payload of 1.5, and a stroke, as you can see, from plus and minus 2 centimeters. So in this case here, this is one of the most successful platforms in the market, the Shake Table 2. Without going into many technical details of the hardware itself, so as you can see, the system also have a bigger platform for a bigger applications in case you are trying to build bigger structures. It have an accelerometer, a DC motor of it, and of course it comes with safety sensors to limit the movement in case the students are exposed to some sort of the solutions. So just to give you a little bit of background about this sort of solution exactly. So we have been contacted, if I'm not mistaken, like somewhere around like 15 or 13 years ago by 23 universities from the US who wanted to adopt structure dynamic solutions. And with collaboration with these universities, we were able to build the Shake Table 2, as you can see here, and it have been adopted by different universities worldwide. So this sort of a platform have been used mainly in education and research. So some of the specifications of the Shake Table, they have a maximum accelerations of 2.5 at a payload of 7.5, at 1G as well at 68 kilograms, sorry, and you have a stroke of plus or minus 7.5 centimeters. So have a fair good stroke to start to imitate earthquakes that you can adopt in it. So I'm going to show a short video here of different sort of movement and configurations to use the Shake Table 2. And you have the ability to mount active mass dampers that we provide for vibration studies, or you can develop your own, depending on your own applications. So the other option that we offer with the dual axis is a Shaktable 3. So this dual axis platform that can adopt a higher payload up to 100 kg. So this solution is very suitable for research applications and as well as high-load teaching applications. So some of the specifications of the hardware, as you can see, you have dual axis, you have a high-resolution encoder, two limit sensors, and a linear motor. Some of these specifications that we can talk about is the maximum accelerations of 1G with the payload of 100 kg. So we have tested it as 100 kg, but the system can adopt more sort of a payload. And the stroke on each of the axes is like 10.8 centimeters. So moving forward to a 6-axis platform that we have developed with a payload of up to 100 kg, and it can go up to higher. So the Hexapod, it's a fully documented solutions that Quансar have developed. So a backstory of these solutions, we have been contacted by a professor from New York University, Dr. Venkat, who expressed to us his concern and what type of solutions he's looking at. And we have worked hand in hand in collaboration with him to develop our Hexapod that have been used in different sorts of applications, also in the defense here in Canada and also in the US. So some of the specifications that I could highlight of the Hexapod itself is to have a maximum accelerations of 1G, payload at 15 kg, but you can up the payload up to 100 kg. A stroke on the x-axis will be plus and minus 13 centimeters, y will be plus and minus 7.5, and also on the z-axis will be plus and minus 7.5. So I'm going to show a brief video after this one that shows how the Hexapod look like, just a brief demonstration. Also, it will show some of the applications that it have been used at. So here we'll show some of the motions that the Hexapod can do. So we have the x-axis translation. Then after that, this will show the y-axis translation for different type of applications or research, depends on what you're looking to adopt. This is the z-axis translation itself. So as you can see, the system moves smoothly without any interruption. And it also have that role in the rotation. So it can move in X and Y and Z. So it is an example of imitating or driving and flight simulator in on the moon. So this have been adopted by us in the office. And as you can see, the system can actually take a load up more, a person sitting on top of it. So definitely it can take up to 100 kg or more for high load applications. So moving forward, so this will show you an overview of the connection of our platforms. It's very easy to set up and it requires almost no maintenance and it's very robust. So the system is very student-proof and can fit in a lab. So adopting these solutions, you can adopt 3 or 4 or 5 or 7 sort of platform in the lab, depending on how many students you have. And also you can adopt them in the research applications as well. So moving forward after that to the software side. So we support LabVIEW, MATLAB Simulink with Quark, our own software, which allows that real-time communication with the hardware. And we also give sample controllers for that. On another note, on the left-hand side, as you can see, we have developed our own software that runs basic tests such as sine wave, sweep, and we have provided with it 4 earthquake samples. And you can also download earthquake data from a trusted website and upload them directly on the software itself and run them. And also, these solutions with the software that we have developed, you can save the data for further analysis as well, that you can share with other researchers, or you can share with the students for further analysis at home for their assignments and labs. So all of our solutions are open architecture, and they come with a courseware that is tailored for your teaching applications. Teaching applications. So the courseware will have two versions in it. The student version that does not have the answers or to the solutions, and the professor version or the instructor version have the examples and also examples and solutions to the labs and experiments that we offer with it. So as I mentioned before, you can add our mass damper to the platform. So either with one floor, with an active mass damper, or with two floors, one of them with an active mass damper, and the first floor will be with the passive mass damper. So as you can see here, this is the building demonstrations, and you have the option to add your own structure if you would like to. So instead of adopting our own active mass damper, you can build your own structure, and I'm going to go into some details into that. And you can mount it in our shake table, connect it to our DAC, and start getting data out of it. So as you can see, our systems are fairly adaptive to different applications, depending on what you wanted to do in your either teaching or research applications. So here's an example of some of the universities who are using our tables to motivate first-year students and bring that theory to applications. So what we are trying to do, we're trying to bridge that gap between application and theory for students who are overloaded with abstract math and physics, and give them that ability to implement their ideas and have a visual implementation of how the structure would look like and how sort of an earthquake will affect sort of a structure itself. So moving forward into that, I'm going to show you an example of a class who is utilizing our shake table with the custom structures that shows the showcase vibration for students. So I'll leave you with the video, and it will show two sort of examples using an earthquake that is not sort of like affecting the structure itself. It's not completely damaging. And the second one will show a damaging earthquake that will be implemented using the shake table. Now moving to the collapse side, which is implementing an earthquake that is damaging to that structure. So this will give the students the ability to analyze and understand how that sort of vibration will affect the system itself. So now moving forward to the research area. These are sampled research areas that our platforms are the ideal solutions that you can use them in them. So we have a huge list of research papers that are published using our shake tables, and you can use our shake tables to either study structural dynamics, base isolation, smart structures, soil analysis, bridge wave loading, and different other sort of like research areas that have been already targeted with different partners from all over the world using our shake tables. So I'm going to show here an example of the structure that is mounted on this shake table was designed by the professor himself. So he did not get our smart structure, which is the active mass damper. So in this case, the professor only opened the box. So as you can see, it's easy to implement, easy to connect. So, and open the box with provided computer and also the control, which is the black box that you see right there. And he will have the ability to design his own neural network-based controller. And as you can see from the connection, it's very simple. And he was able to publish his paper on the 7th IESE, which is the International Conference on Advanced and Experimental Structural Engineering conference. So at the bottom, you can see the sample neural network that he was able to implement using our shake table. So definitely using some of our platform, you have that ability to target different sort of like research applications that are not just like implemented in just regular structures. Moving forward, so here is an example of decentralized active control with the wireless sensor nodes. So from the picture that you can see here, it shows the control feedback configurations in 3 different scenarios. And the professor was able to publish, or the authors were able to publish their research paper based on Quanser solution using either censored or non-censored sort of structures. So moving after that, so this video will show an example configuration of a university using 2 shake table trees with a mountain structure itself. So for their application, using LabVIEW as sort of a software. So they can use various structures either with frictional or non-frictional surfaces as well. So the advantage of this solution is that you can place a bridge with one pillar on a shaker and another pillar on the other shaker. And both of these shakers, as you can see here, are connected to the same computer, which the same computer or the same control system. This replicates an earthquake that is coming from sort of like down earth. And as you can see, when it comes to bridges, one of the pillars will receive the wave before the other one, or both of the pillars will receive the wave at the same time. So you have that ability to do that sort of application. So with this sort of setup that you see here, it will bring that more realistic approach to real-time or real-life scenarios. And with those two shake tables, as you see here, you have the ability to mount structures that go up to 200 or 250 kgs in them. So it's pretty more realistic to what it's coming on real life. So this will sum up our introduction to our structure dynamic solutions. And I would like to thank you all for making the time and assisting to our webinar. And please feel free to share your questions in the comment section. We will be more than happy to answer them. Thank you all today.
Thank you, Isa, for this excellent presentation, and thank you to Vishaan. Guys, this is the right time. If you have any questions, please feel free to post them on the chat box, or you can simply direct them to our audience or to our presenters. Any questions?
Ralph?
Yes, Dr. Jamal.
You know, it's a great products, and definitely for structural dynamics, vibrations, lots of things to do and to bring to life a lot of these courses for students. What I wanted to probably maybe it was by design. I think the health monitoring of the side of the talk. I'm not sure if I missed something or not in terms of having like the different kind of sensors, whether wireless and otherwise, that you can communicate and collect some real life data. I'm sure in your Kwanzaa's inventory of maybe these technologies, and tying it to the even like the Internet of Things. I mean, everything is smart nowadays, and definitely you can mimic that even in a structure of sorts, just like the truss structures you show, the buildings mimicking. I've seen Burj Al Arab and others that they put the picture. That's a nice touch. But getting back to the health monitoring of structures in terms of having maybe strain gauges, accelerometers, maybe other types of sensors, and wireless or even tethered in many different ways. And I'm looking at, did I miss that, or I'd like to hear from you.
No, this is exactly the topic. This is the talk of the town, actually. Like, you know, even you mentioned Burj Al Arab. We have another good example, which is Burj Khalifa. Burj Khalifa is actually continuously monitored by similar system based on data acquisitions and similar algorithm. And we are witnessing how the change of the structure, expansion, change in the temperature, like the top temperature is different than the bottom temperature, and how the top structure is moving roughly 1 meter compared to the reference ground. And this is something that is 24 hours continuously monitored through smart sensors and modeled in such a way where we can prevent any accident. This is something also valid for dams, like for bridge dams, a very important structure that we are nowadays requiring this as a must for it. Were I able to answer your question, or is there anything else that I missed?
Could I expand on that as well?
Yes, Vishaan, please feel free.
Yeah, thank you. And great question, Dr. Jamal. With regards to Kwanzaa's positioning, you actually hit the nail on the head. We purposely don't prescribe specific sensors or IMUs or accelerometers that can be leveraged to get you the actual granular data that you're looking for on a structural health monitoring standpoint. The reason for that is because of our solutions and the way we support the actual research. And let me be very clear. An example of this is I was working with Dr. Labula out at University of Sharjah, and his effective research was to do structural health monitoring on unimorph structures, so effectively structures that are not traditional in terms of their architecture. And the way Quanser supports that type of research is we have an accessibility for real-time control, so you can utilize our data acquisition devices or partnered solutions such as NIDACs, along with off-the-shelf strain gauges, IMU, accelerometers, and interface with our hardware. So being a global company, we know that there are more cost-effective alternatives out there on the market. So our goal is to provide the accessibility and the interoperability to be able to communicate with the sensors that you may choose to want to work with. So rather than prescribing, even though we could if that was of interest for you, and we can provide a holistic package inclusive of those sensors, we traditionally avoid prescribing just because we know anywhere on the market you can find a varying degree of cheaper options effectively. I'm not sure if that directly addresses what you were asking. Perhaps if you want to clarify if I didn't.
No, I see your philosophy in terms of having an open architecture, and anybody can like instrument and put whatever they want to put on a system that they're testing. So you know, I see that. I understand it. Now, a lot of the systems. I mean, you know, when we teach courses, even on vibration kind of course, we look at a single degree of freedom system. We look at maybe 2 degrees and so on and so forth. And also we look at not just like rigid kind of like structures, but also flexible structures. So if you're to simulate any of those flexible structures, and I wonder now your shaker in terms of input, and you touched on the fact that you can feed some like historic data for like an earthquake or something, and you can probably feed it. Now, equally, in terms of getting an input excitation, let me put it this way, into the shaker, into whatever controls it, any one of those that you looked at, basically, including the 6DOF. Okay, can you like hook up to a function generator, so to speak, and say run a white kind of like noise, kind of like random vibration, and try to maybe research or maybe demonstrate to the students like a resonance of what happens when you hit one of those modes, for example, the natural frequencies of the system itself, and then you get into large amplitude oscillations that could lead to probably, you know, real life like stresses and stress reversals, and then maybe suffer some kind of like a damage, whether it's catastrophic or not. And so my question is can the input excitation be from maybe an NI, maybe virtual even instrument with like a frequency generator or function generator that can mimic anything else that you want? Is that possible or not?
Absolutely, absolutely, and very well said. We have a video actually that demonstrates that exact concept, where we have our Shaketable 2 running with 3 unique structures, and you see the natural frequency being met at the 3 different vibration points. With regards to utilizing additional, be it function generators or equipment, provided that the communication input was able to be interfaced with our hardware, which effectively only requires sensor readings and motor inputs, it should be possible. I'd perhaps invite Hernando to maybe add in terms of his own personal experiences with structural vibrational tables and his own personal experiences with regards to how he's gone about teaching or research efforts.
Yeah, absolutely. Thanks, Vishen. Yes, I see your question. So yeah, absolutely. There are 2 ways to run any of our systems, either with the real earthquakes profile that you can find on internet, actual earthquakes system that you may find. And in addition to that, you can add or create your own profile, either using MATLAB, using Excel, as long as those profiles meet the specific requirements on the checker. For example, you can expect that the acceleration be higher than 2 or 3 years. As long as your expectation fits the specs of the checker, you can do that. You can add your own profiles generated by your own or historical data that you can find. All our systems are provided with 4 profiles for the actual earthquakes that happen in USA and Japan, but you can add another one from any other region of the world. I hope this answered your question. Sorry, are you still there? Can you hear me?
Yes,
we
I
hear
hear
you.
you now.
Okay,
Maybe I
good.
turned on my mic. Yeah, that's great. I understand that. And yes, whether it's a known signature, kind of like earthquake from anywhere in the world, or you can probably do some exercise. And typically, you want students even to be able to see most of the things that students don't understand. They think it's the amplitude that matters the most when you excite a shaker. It's not how like the plus and minus you showed.
But the frequency, Dr.
It's the
Jamal.
frequency. It is the frequency. Now, an electrical engineer may be understanding more than maybe a civil engineer, with all due respect to civil engineers. But the fact of the matter, it is the frequency that matters. Yes. So you want to steer away from natural frequencies of the structure to. Yeah, that's good. I'm happy to hear this. By the way, that 6 DOF kind of system, I think that could be of interest. Even in mounting anything else, it could be like a driving simulator. I know you had the seat bucket that somebody sits in it, but can be like simulating like a hubcap for a car, or looking at the suspension system, look at the auto industry, and maybe even you can look at maybe like a sort of like simulating a crash worthiness, maybe from an auto industry. And there are a whole lot of things that you can dream and do research on it. So that's really good. I'm impressed. That's good.
Thank you,
Great,
Dr.
thanks.
Jamal.
Yeah,
Thank you, Dr. Jamal, for this very nice feedback. So in addition to the frequency, it might be also the wave. It might be a combination of several frequencies, or like a pattern, like the right question of Mr. Wael or Dr. Wael right now. He's asking also a good question: how easy it is to apply different loading function to the products? Do they allow real-time changing of functions pattern? Konzer team?
yes.
And
Sorry, could you please repeat a little bit the question?
yeah, so if I understood correctly, that whenever you are applying, I know it because I know the shake table philosophy. Like when you are applying different signature or different earthquake models or different function pattern, the question is, do these product, or does this product allow real-time changing of functions pattern, and how easy is to apply those different functions?
Well, basically, what we normally do with those functions that you can create is that you need to create that as a text file. And those text files are loaded into the MATLAB workspace. And basically, that's what we normally do, is creating the profile in text file, and it is applied either to the 1-axis or 3-axis, depending on the shaker, if it's 1-axis or the XY T-axis or the hexapod 3-axis. Just basically have to do that. We provide some examples that you can see how the template should be, and from there it's easy to modify, adapt. In fact, we provide one of the examples in which you use sine waves in different frequencies and amplitudes that you can customize according to your needs.
Yes. Thank you so much for the answer. Mr. Wael, did we answer your question? And until we receive an answer from Mr. Wa'el, I would like also to share my experience using the Quonsor Shake table. That as a user, it was an amazing feeling how you can run some models with the interface of LabVIEW. Like you can have some earthquake signature, like the Japanese type or the Mexican type or whatever it's well-known type of earthquake that you might think of, and then you can apply it and see the response of the platform. And regarding the changing in real time, I guess you have to load the new example, and then it will show the result afterwards. In addition, if your complete pattern or your complete model include a variation, so this variation it has to be normalized and then downloaded to the hardware in order to be able to execute it. Does this answer your question, Mr. Wa'el? I guess we lost. Yes, thanks a lot. You are welcome. Any other question, guys? Anybody from Quonsor would like to comment on this same question before we close the session?
No, basically that has been covered. Just wanted to add a little bit about the sensors, specific sensors that now are being used, monitoring structures. Yeah, absolutely. Yeah, there are multiple ways to do, as Tuvishan explained, that acquisition system that can be either Quonsor's or someone else's. But basically nowadays, all civil engineers are adding in the actual structures a number of sensors that monitor the structure as is being built, the actual, the real building. So here, with our system, you can replicate some of those, exactly adding extra accelerometers. Quonsor provides sets of accelerometers that you can add to your designs and others from somewhere else. So basically, all the capabilities are there to add sensors such as accelerometers, inclinometers, even temperature sensors, strain gauges, stuff like that. We provide all the assistance in any case you want to add. Beautifully, Ralph, also for mentioning about LabVIEW. Yeah, LabVIEW and MATLAB both are supported in our system. Yeah, thanks.
Yeah, I had the chance actually to try it, the shake table on LabVIEW. That's why I was sharing my experience. Thank you so much for the feedback and the comments. It seems that we don't have any other question to answer right now. I would like to thank you, Quonsor team, mainly Tuvishan, Isa, Hernando, and for sure Murtada. With this, I would like to return to. If you have any other question, please feel free to contact us, and we'll be more than happy to answer you. Our event reached its end. Thank you for your questions, feedback, and most importantly, thank you for your time. We are very honored to have you in our event and future events as well, as I mentioned at the beginning of this webinar. Please reach out to me or to us for any further questions. We'll be more than happy to hear your problems, challenges, and provide you with the right solution. Have a great day.
Thank you all.
Thank you all. Bye-bye.
Thank you.